Hi everybody. Right now we're going to do the worksheet 4.4 to 4.5, 1 to 10, and 21 to 25. So this is a homework assignment, and I'm going to work through each of the problems. So if you had any trouble with any of these, just go ahead, go back, listen to it again, whatever you need to do, so that you have 1 to 10 and 21 to 25 on worksheet 4.4 to 4.5, all straightened out. Here we go. Problem 1, y equals 2 sine x. Now I think what I'm going to do is, for reference, I'm going to put my basic curves over here on the side, along with the basic labels. We went over this in class, and this is something that you are supposed to know. So I'm going to go ahead and put this here because it helps me for my own reference. And it might help me as I start changing some of these numbers in the problem. So I have graphed a sine. This is my cosine. And I'm going to squeeze my tangent in down here. We haven't done much with the tangent. And the tangent wasn't part of your homework. It wasn't part of this assignment, but it will be part of the next assignment. So I'm going to go ahead and have all of my regular pictures here for my reference. So I'm going to remember that the amplitude is 1 and the period is 2 pi for both the sine and the cosine. For the tangent, there is no amplitude, and the period is just pi. Now, one more time, groupies, I know you hate memorizing stuff, but this needs to be known. You need to know this in order to do these harder problems. So here we go. Sine 2x. Remember that a number in this position multiplies the amplitude. So I have a sine curve that is now twice as high as it was in the beginning. This sine curve now goes up to 2 and down to -2. Nothing horizontally has been changed, so all of these labels are going to remain the same. So we'll keep it at pi over 2, pi, 3 pi over 2, and 2 pi. Now, I would like to emphasize again that these are angle measures, and so they can be expressed in radians, which is how we are doing it. They could also be expressed in degrees, and with another set of directions or another teacher or something, these could be done in degrees. We are doing them in radians. These labels don't change unless you put a number in there, which we don't have one. So these numbers stay the same. And that's it. Our amplitude, it says list the amplitude and period. So the amplitude is 2, and the period is still 2 pi. Next. Now, we got a couple of things going on here. First of all, there's a 1/3 there, and we know that is going to multiply the amplitude. But it's also a negative. That turns the curve upside down. So instead of starting at the top of the hill, this curve is going to start at the bottom of the valley. So it's going to start down here and end down here. Remember that the curves always end where they started. So if it starts at the bottom of a valley, it's going to end at the bottom of a valley. Notice there is no number in there. We didn't put any new number in on the x, so these labels stay exactly the same. They are not changed. Amplitude of that curve is 1/3. Now be careful, I know there's a negative out there. Amplitude is never negative. So even though there's a negative 1/3, even though there's a negative sign there, all that does is turn it upside down. It does not change the sign of the amplitude. Now we got some big things happening. we have a sine curve. It's right side up, and it's 4 times as tall as it's supposed to be. So it's going all the way up to 4 and all the way down to -4. It's a sine curve. And it's going up 4 and down 4 because this number multiplies the amplitude. So now my amplitude will be 4. My period has been changed. We snuck a number in here. This number divides the period. Now, your period is supposed to be 2 pi. So your new period will be 2 pi divided by 2, which is pi. That means that all of your labels are divided by 2. Each of your labels, your sine curve, is divided by 2 or timesed by a half. So if you times this one by a half, it would be pi over 4. If you times this one by a half, it would be pi over 2. If you times this one by a half, it would be 3/4, 3 pi over 4. And of course that one times a half is 2 pi, or is 1 pi, 1 pi. Now, again, the reason that we took all of these numbers times a half was because this number divides the period. And when I'm working with fractions, instead of thinking divided by 2, I think times 1/2. So I take 1/2 times all the regular labels, and that's how I get the new labels. Perfect. All right, let's look at number 4. Again, we've got a couple of changes being made in our problem. This is a sine curve, but it's upside down. See the negative? So you're going to have your valley first and then your hill. Remember, a sine curve has a hill and then a valley. Because this one is upside down, it will have a valley and then a hill. The amplitude is 2. And the period has also been changed because of this number right here. Remember, this number divides the period. This number multiplies the amplitude. That's how the amplitude got to be 2. Your normal period, remember, is 2 pi. So we have 2 pi divided by a half, which is 2 pi times 2, or 4 pi. So my period is now 4 pi. Everything is getting doubled. All of your labels are getting doubled. Why are they getting doubled? Because they're being divided by 1/2. And dividing by 1/2 is the same as timesing by 2. So if I take all my labels and times them by 2, take 1/2 times 2 and you get 1. Take 1 pi times 2 and you get 2 pi. Take 1.5 times 2 and you get 3 pi, and the last one is 4 pi. Again, I simply took each of my regular labels and took them times 2. Oh my, look at number 5. Scary for sure, but we won't be afraid. This number is going to multiply your amplitude, and this number is going to divide your period. So we have a handy dandy cosine curve. It's positive, So it starts at the top of the hill, ends at the top of the hill. Now its amplitude is only going to be a fifth. It's kind of a short little curve. Short, only 1/5 tall. And what's its period? Well, it's supposed to be 2 pi. All cosines are supposed to be 2 pi. But we put a number in there, so it's 2 pi divided by a tenth, which is 2 pi times 10, which is 20 pi. So your period has been times by 10, divided by a tenth, times by 10. That means that all of your labels are times 10. So the first one, if you take it times 10, 1/2 times 10 would be 5 pi. Pi times 10 would be 10 pi. 3/2, or 1.5 times 10, is 15 pi. And the last one is, of course, 20 pi. That is your period. Each of these labels got timesed by 10 this time, because that number divides. Divided by a tenth means times 10. Well, shoot, after that one, this next one looks kind of easy, doesn't it? What's going on in this next one? It's 3 cosine. So it's a regular old cosine curve. Starts at the top of the hill, ends at the top of the hill. Its amplitude is 3. And what's its period? Notice there's no number in there. So what's the period? You're right, it's just 2 pi. So all the labels are the regular labels. You don't have any changes because you did not put a coefficient in there. If there's no coefficient on x, the period stays 2 pi. This one stayed 2 pi. We got 2 numbers in here again. That means we're going to change our amplitude. It's a sine curve. Our amplitude is 2. And we're going to change our period because we put a number in there. So what's our period? Well, it should be 2 pi. Remember, the period of a sine and a cosine is always 2 pi in the beginning. But then we put a 6 in there, so it's divided by 6. That means all of our labels are going to be divided by 6. Now, kids, these are fractions, so instead of dividing by 6, you can think of it as multiplying by 1/6. So if I look at my original labels, I don't want you to be confused by this. You can do this. I look at my original labels. I need to divide these by 6. I don't want to divide them by 6. I'm going to multiply them by 1/6. So what do I get here? If I take pi over 2 times 1/6, what will that label be? That label will actually be pi over 12. This one will be pi over 6. This one, now when you multiply, you get 3 pi over 12. I am not going to mark that wrong, but that does reduce. You might want to make it pi over 4. And likewise here, I get 2 pi over 6, which you might want to reduce to pi over 3. So your labels are pi over 12, pi over 6, pi over 4, pi over 3. Each of the regular labels times a 6th. we got another one that looks like a doozy. Okay, it's a sine curve, but do notice it has a negative. So you remember what that means. For the sine, that means valley first. The amplitude is 10. So I'm really not drawing mine to scale very well. Those are very, very tall. They are very tall. They're 10 units tall. Now my period has been changed. This number, remember, divides the period. So my normal period is 2 pi. I have divided by 1/3, which is the same as timesing by 3. I've divided by 1/3, which is the same as multiplying by 3. So all of my regular labels are going to be timesed by 3. So this one is normally 2 pi, so it will be 6 pi. This one is normally pi, so it will be 3 pi. This one is normally 1/2, so it will be 3/2. And this one might give you some trouble. Remember, it's normally 3/2. So when you take it times 3, you will get 9/2. Again, you can do the arithmetic. Do not panic, do not whine. You can do it. Number 9. Again, we have 2 numbers in the problem. That means we're changing both our period and our amplitude. It's a positive cosine. Starts at the top, ends at the top. Its amplitude is 1/3. Remember, this number multiplies your amplitude. The amplitude is supposed to be 1. We got a 1/3 out there. Now the amplitude is going to be 1/3. Our period has been changed. It should be 2 pi, but now it's been divided by 4. That means that all of your labels, I'm going to put in the regular labels, these are the regular labels, all of them are timesed by, they're timesed by 1/4. Dividing by 4 is the same as multiplying by 1/4. So I'm going to take each of these times 1/4. What am I going to get when I do that? Well, pi over 2 times 1/4. Just step aside for a second. The reason I'm timesing by 1/4 is because this number divides the period. Dividing by 4 is the same as timesing by 1/4. So I have pi over 8, pi over 4, 3 pi over 8, 2 pi over 4, which if you want, you can reduce that to pi over 2. So your period is actually pi over 2. One more of the graphs, and we got that other kind of problem to do. Y equals -3 cosine 1/4 x. So now we've got a cosine curve, but it is negative. So it starts at the bottom of the valley and ends at the bottom of the valley. Negative cosine curves start down here and end down here. They're upside down. I need to put my labels in there. So the amplitude is 3. And the period should be 2 pi, but it's been divided by 1/4, which means it's actually been multiplied by 4. 2 pi divided by 1/4 is 2 pi times 4. So all of my labels are getting times by 4. This one was 2 pi, now it's 8 pi. This one was pi, now it's 4 pi. Everything's getting times by 4. This one was a half, so now it's 2 pi. This one was 3 halves, so now it's 6 pi. And there is your curve. Okay? I'm going to go ahead and erase the sine and cosine now. In a minute, we're going to do some work with the tangent. In another video, we'll do some work with the tangent. So I'm going to leave him here. We're going to do the cosine of 120. So the cosine of 120, you know what to do. You've done a lot of these. You're going to draw your circle. And in that circle, you're going to recognize that's 90 and that's 180. So 120 is over here. The angle you want is always the one inside the triangle. So you're going to look at 120 to 180, and you're going to say that's 60. Across from the 60 is root 3. So you'll finish labeling your sides. Some of you are still struggling with that. You must memorize that across from the 60 is root 3, across from the 30 is 1, and the hypotenuse is 2. Anything negative in there? Yep, you're right. That's negative. We went left and up to get this angle. This angle goes left and up, so therefore we have a negative here and a positive here. Cosine is adjacent over hypotenuse. The answer is negative 1/2. Sine negative 60. Negative angle means we go down. So this is 0. This is negative 90 if we're going down. So negative 60 is in here. This is a 60-degree angle. We're coming down 60 degrees. So we have exactly the same kind of triangle we had there. We're going to put a root 3 here, a 1 here, and a 2 here. This time, though, it's the root 3 that's negative because we came left and down. We want the sine. Negative root 3 over 2, because sine is opposite over hypotenuse. Tangent pi over 6. Probably the first thing you want to do is rethink the pi over 6. Pi is 180, divided by 6 is 30. So we're really finding the tangent of 30 degrees. 30 degrees is right here. It's between 0 and 90. This angle is 30 degrees. That's a 1, that's a root 3, and that's a 2. No negatives this time because we went right and up. Those are positive. We want the tangent. The tangent is opposite over adjacent. That's 1 over root 3. Let's rationalize that by timesing the top and the bottom by root 3 to get root 3 over 3. As the answer to question 23. Number 24 is the secant of 3 pi over 4. The secant of 3 pi over 4. All right, let's do what we did before. Let's get that guy changed into degrees. So pi is 180 divided by 4 is 45 times 3 is 135. So we're going to find the secant of 135 degrees. 135 is in quadrant 2 because it's between 90 and 180. It's over here. Here's my butterfly bow tie. How far is it from 135 to 180? 45. So my sides are 1, 1, and my hypotenuse is root 2. Again, you are expected to know that the sides of a 45, 45, 90 are in the ratio 1, 1, root 2. Anything negative? Yep, right here. Again, this angle is going left and up. Left is negative, up is positive. We want the secant. The secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. It's my thought process. Hypotenuse over adjacent would be negative root 2 over 1, or just negative root 2. And finally, the last problem is the cotangent of 180. 180 is very special. 180 is right here. It is on an axis. Remember, when the angle is on an axis, we cannot build a triangle. Instead, we need to figure out our x, y, and r values. The cotangent will be x over y, because tangent is y over x. So I need to figure these out. So I make up a radius, and I like to use a radius of 1. If this circle has a radius of 1, then this is the point where x is negative 1 and y is 0. Over 1, up 0. This is the point negative 1, 0. Which means that our cotangent will be negative 1 over 0. You can't sit on the egg, so that is undefined. And that's it for that homework assignment. Have a great day.